Good day everyone, I'm Shalamay Laura and today I'll be discussing my topic relating density, specific gravity, mass, and volume to each other. In this report, we'll learn how these four physical properties are connected and how they help us understand the behavior of different materials. Before we start, here's an overview of the key concept we'll talk about: density, specific gravity, mass, and volume. Our objective for this lesson is to explore and understand how these physical properties relate to each other using examples and formulas. So, what is density? Density is defined as a mass of an object per unit volume. In simpler words, it tells us how tightly matter is packed inside an object. For example, if you drop a piece of ice in a metal ball into water, the ice floats while the metal ball sinks. That's because ice has lower density than water, while the metal ball has higher density. So, density helps us predict whether an object will float or sink. Now, let's talk about mass. Mass is the amount of matter an object has. No matter where the object is on Earth or in space, its mass remains constant. For example, a suitcase has the same mass whether it's being carried or placed on the floor. Mass is an important factor in finding the density of an object, since the formula for density uses mass and volume. Volume measures how much space an object occupies. It can change depending on the object's shape or state, solid, liquid, or gas. For example, when you squeeze a balloon, its volumes become smaller. When you heat it, the balloon expands. This example shows how gases can easily change their volume. Now, let's discuss specific gravity. Specific gravity is the ratio of a substance's density to the density of water. It helps us know whether something will float or sink in water. For example, an artist comparing clay, stone, and metal will choose materials based on their specific gravity to know how heavy or light they are compared to water. Here's how these properties are related. Density connects mass and volume. If the mass increases but the volume stays the same, the density increases. For example, if we have two containers of the same size, one filled with feathers and one filled with rocks, the rocks have more mass and therefore higher density. This shows how changes in mass and volume affects an object's density. Specific gravity is directly related to density because it compares a substance's density to water. If an object's specific gravity is less than 1, it will float, but if it's greater than 1, it will sink. For example, a marine biologist might observe that fish with lower specific gravity floats more easily, while those with higher specific gravity sinks deeper. Here are the formulas we use. These formulas help us solve problems and understand how mass and volume affect density and specific gravity. Now, let's move on to the exercise part. The problem says a solid metal block has a volume of 0.02 cubic meters and a mass of 160 kilograms. We are asked to find the density of the block, the specific gravity of the block if the density of water is 1000 kg per cubic meter, the mass, the volume, and density of each piece if the block is cut into two equal parts. Let's start with the first one, finding the density. The formula for density is density is equals to mass divided to volume. Now, I will substitute the given values. Density is equal value of mass is 160 kilogram divided by the value of volume is 0.02 meter cubic. Now, let's get the final results. It's 8,000 kilogram per meter cubic. So the density of the metal block is 8,000 kilograms per cubic meter. Next, let's find the specific gravity. The formula for specific gravity is specific gravity equals to density of substances divided by 2 density of water. We already know that density of the substance is equals to 8,000 kilogram meter cubic, and the density of water is 1,000 kilogram per cubic meter. Now let's divide 8,000 by 1,000. Specific gravity is equals to 8. So the specific gravity of the block is 8. This means the metal block is 8 times denser than water, so it will sink if placed in water. Now, the third question: if the block is cut into 2 equal parts, what will be the mass, volume, and density of each piece? Since the block is divided equally, the mass of each piece is equals the mass of each piece equals 160 divided by 2 divided by equals the mass of each piece. The volume of each piece is equal to 0.02 divided by 2 is equal to 0.01 meter cubic. Now, check the density again. Density is equals mass divided by its volume. Now, our mass is equals to 80. The volume is divided now into 0.01. So our density is 8,000 kilogram per cubic meter. In conclusion, for the density, we've got 8,000 kilogram cubic meter. Specific gravity is equals to 8. Each half has 80 kilogram mass, 0.01 cubic meter volume, and the same time density of 8,000 kilogram per cubic